In this video, we're going to do a little more work with probability as well as introduce a fifth rule from our rules that we started talking about in a previous video. The probability of a random South Campus student taking pre-calculus is 0.15 and taking AP calculus is 0.21. Notice those two things are disjoint, meaning you can't take both at the same time. So what is the probability that a randomly chosen student is in pre-calculus or AP calculus? Well, this is going to be 0.15 plus 0.21. So I'm kind of out of room. It's 0.36. Okay. What's the probability that a randomly chosen student is not in AP calculus? So this is where we're going to use our complements rule. We're going to say, well, we're going to do 1 minus 0.21 and get 0.79. Sorry that don't have much room for circling here. What's the probability a randomly chosen student is not in pre-calculus or AP calculus? Well, for this one, we can subtract the answer we got for the first one, right? The probability they were in it was 0.36, so the probability they're not is 1 minus 0.36. A survey was conducted on what sport was most enjoyed on television. The results are displayed. What is the probability that a person said baseball was their favorite sport to watch on TV? Well, the first thing I'm going to do is just kind of fill out an overall total here for some of these categories. So you can see we have 40, 62, 62 plus 15 is 77. So we had 77 males part of this survey. Okay. For females, 12 plus 16 is 28, plus 45, so we have 73 females that were part of this survey for a total of 150 people. So the probability a person said baseball was their favorite sport to watch on TV is 60 out of the 150. And I'm going to write that. I'm not going to calculate it as a decimal, right? It's 6/15. You could divide that by 3 and get 2/5. I guess I could. It's 0.4. What's the probability that a male said football was his favorite sport? So if we said a male, we're saying, well, we're only looking at these 77 now. So 40 out of 77 of the males. Now, the question sometimes comes up of how would you know that it wasn't 40 out of 150? It's really in the wording of the question. If the question was worded as, what's the probability that a randomly chosen person was a male who liked football, then you would be saying, okay, out of all of the people, out of all of the 150, I picked a male that liked football. But this began by saying it is a male, right? What's the probability football was the favorite? So that's why it's 44 out of the 77. Next, what's the probability that a female, so again, we're only talking about females here, we're only talking about these 73, said basketball or football, so we're saying, all right, that's 12 plus 16, that's 28 out of 73. And again, the other wording, if it was going to be out the 28 out of 150, is what is the probability we randomly chose a person and it was a female who liked basketball or football. So, another example. At South Campus, 30% of students are taking Algebra 2, 8% are taking Calculus, 10% are taking Statistics, 15% are taking Pre-Calculus. And I should be clear here, Calculus I meant was BC. So, which of the events are disjoint? Well, quite a few pairs here. Maybe I'll just talk about them. Algebra 2 and Calculus are disjoint. You can't take both at the same time. Algebra 2 and Pre-Calculus and Statistics are disjoint. You can't take them at the same time. Algebra 2 and Pre-Calculus are disjoint. You can't take them at the same time. Calculus and Pre-Calculus are disjoint. You can't take them at the same time. However, you can take Calculus and Statistics at the same time, and you can take Statistics and Pre-Calculus at the same time. So, the probability of taking Algebra 2 or Calculus, I guess the big thing I wanted to point out is these two are disjoint, meaning we can just add them up. We can say it's 0.30 plus 0.08. It's 0.38. I'm just going to move on. What's the probability a student is taking pre-calculus or calculus? Again, these two are disjoint, meaning we can just add them up. So pre-calc was 0.15, calculus was 0.08, like that. Now, what's the probability a student is taking calculus or statistics? This example is not disjoint, so we don't know. Can't answer it because we don't know how many students are taking both. Now, the next question says, if you knew that 1% of students were taking both, could you find the amount? Now you could. You could say, well, there are, 0.08 proportion taking calculus, 0.10 taking statistics, and we subtract off the 0.01 that we're taking both. This leads us to a new modified addition rule. So our problem really is the fact that if events aren't disjoint, we need to know what the overlap is. We need to know what belongs here, the probability of A and B. So our rules yesterday, or in the previous video that we talked about, were up here. We have a modified addition rule. The probability of A or B occurring is equal to the probability of A plus the probability of B minus the probability of A and B, because in events where the events weren't disjoint, we would have counted them twice. We would have counted that overlap twice. So, in the event they are disjoint, you have to remember the probability of A and B is 0, because disjoint means they can't overlap. So, this is a new modified addition rule, and it's actually the rule I think of most of the time, because in the event that things are disjoint, you'll just substitute 0 in for this last piece anyways. Let's look at an example with a Venn diagram. So the probability of event A is 0.4. I'm going to just write event A right here. The probability of event B is 0.2. The probability of A and B is 0.05. I always begin with what's in the middle. Okay, I'm going to put a 0.05 there because it helps me fill out the rest. I know then that 0.35 belongs here and 0.15 belongs here. And let me just explain. The probability of A was 0.4. So you have to say, well, the entire circle needs to include a proportion of 0.4. Just like the probability of B was 0.2. So the entire circle needs to be 0.2. I always like to also figure out what's left over. Okay, so I think, well, 0.35 A alone, 0.05 for both, so this is 0.4, plus 0.15 for B alone. So 0.55, that proportion is within the circles, so 0.45 is left over. So that's the whole sample space. A alone, B alone, A and B, and neither one. Okay, so again, A alone, B alone, A and B, or neither. So the probability of A or B, we'd already kind of calculated. This is simply adding these three values up. A or B, when you see this, which also I should just write the more mathy way to say this is A or B with that U for union. That implies both. Okay, so it could be one, the other, or both. So this is the sum of the two circles alone and then the overlap. Now the probability of A complement, well, remember the probability of A was 0.4, so the probability of not A is 1 minus 0.4. And the way you'd see that in the Venn diagram is by adding, of course, these two that aren't part of the A circle together. The probability of A and not B. So now you're within A, but not part of B. So it's only this 0.35 right here. The probability of not A and B. So now we're talking about you are included in B, but not inside A. So it's just the 0.15. And finally, the probability of not A and not B. So now you're not in either circle, So you're the 0.45 that is left outside.